Hi, I wanted to break up a second video here, and I just want to talk about like the idea that we're talking about how you translate, like A or B are just simple statements, and then you begin to go like A dot B or A wedge B or A horseshoe B. These are what we would call compound statements. The letter itself is a simple statement. This is a compound. But the thing about compound statements is they can get very complex. A lot of times you say stuff like, Al and Bob will be here, but not Cindy. Al will be here if Bob and Cindy are here, or something like that. And so then, if you said Al will be here if Bob and Cindy are here, if signals the antecedent. So Bob and Cindy is just that. Then if signals that's the antecedent, and then the consequent is Al. And so you would translate that way. So what happens is you can have statements that have parentheses and get very long and complex. So it becomes kind of an idea that we have to have a way of doing what we call a well-formed formula. Put that upside down. So well-formed formula. And so what happens is well-formed formulas are basically how do you write something that makes sense when you get 2 or 3 operators in a row. The idea here is just like in math, like if you have a statement like 4 plus 4 divided by 4 equals what? Well, the thing is it's going to make a big difference if you mean 4 plus 4 divided by 4, if you mean this, or if you mean this. Because if you do 4 plus 4 with 4 plus 4 in parentheses, then you get 8, and then you divide by 2, and you get 4 as your answer. However, is that right? No, I'm sorry, you're dividing by 4, not 2, sorry. So you get 2 as your answer. I was like, that doesn't make sense. Okay, sorry. So, but then if you do 4 plus 4 divided by 4, but 4 divided by 4 goes first, that's 1, so it's 4 plus 1, which equals 5. So where those parentheses is makes a big difference. Now, in certain problems like 4 plus 2 plus 7, it doesn't matter if you do this first or this first. I mean, that doesn't make a difference. But we would still, for logical purposes, we would still go ahead and put parentheses around it. And so what happens is you need to always have parentheses. If you have, kind of the one, there's sort of there's two categories. There's the category of those statements where you have the letter tilde, and then you have dot, wedge, horseshoe, and triple bar. Dot, wedge, horseshoe, and triple bar always go between, they always show a relationship. These always show a relationship between 2 statements. So these always have to go between 2 statements. So it could be 2 statements like A plus B, or it could be A plus B parentheses wedge C horseshoe D. It now has this is a statement and this is a statement because the parentheses have brought it together as one statement, this is another one, and it's there. So you can never go and have 3 letters in a row without parentheses. You can never have 3 letters. The other thing is anytime you have letters, you always have to have some sort of relationship. If I say AB, what does that mean? Amy is here, Bob is here. Does that mean dot and? Or does that mean Amy is here or Bob is here? If Amy is here, then Bob is here. What does that mean if you do that? You can never put 2 letters together, okay? You always have to have one of these symbols that always shows what the relationship is between the statements. But if you have a compound statement, you can also add on something to relate it to yet another simple or compound statement. And you can even go on and you can have brackets and more bigger brackets. I mean, you can have very long statements as long as you maintain that you always have, like if you have A dot B horseshoe C wedge D triple bar E wedge F, that doesn't mean anything because it's like that math problem of 4 plus 3 divided by 7 plus 8 divided by 2. I mean, you need parentheses in there. So you could add parentheses in here like this, and that could work if that's what it means. But it's also the case that really every statement can only have one main operator. And in this case, it could be this or it could be this, because this is showing the relationship between these two, and this is showing the relationship between these two. But now we've got a statement like A horseshoe B, or I'm sorry, let me use lowercase letters are used for symbolizing a set of, like, we usually use lowercase to symbolize like A dot B, and A is a simple statement, P is a compound or complex statement. So we have basically P horseshoe Q horseshoe R, where R stands for E wedge F, Q stands for C wedge D, and P stands for A plus, or A and B. And so what happens here is we now have this, I'm sorry, and that's a triple bar, not a wedge. So just to make note of that. So let me just do that. P horseshoe Q triple bar R. Well, now we don't know if these two are together or these two are together. So what we would need to really do is we would want to do it where you have brackets, and it could be there or the brackets could go here. But the idea there is you never have, this has a statement with a triple bar between it. This becomes one big statement with a horseshoe between it and this statement. And so you just kind of have to keep in mind there always should be one operator, and one operator that controls kind of the whole thing. Now, we haven't talked about tilde. All tilde does is negate, and it can negate both a statement, both a compound statement and a simple statement. It can negate something like A dot B, but it can also negate just the letter A. And so what happens is you can, the only exception is dot is showing a relationship, but A is just negating the statement that follows it. So if you put a tilde and then you put dot B, this is negating the letter A. But if you put parentheses like down here, then the tilde is negating everything inside the parentheses, so it's negating A and B. This is saying not A and B. This is saying it's not the case of A and B. And so you can actually put A dot tilde B. You can have a tilde in front of a letter, and you can have it in front of parentheses. You can never put tilde dot, because tilde has to go in front of a letter or parentheses. It's negating what follows it. And you can't really negate a relational concept. And so those are a couple things to keep in mind. And basically what you're going to do is you're going to use this in order to be able to symbolize statements. And so when you get some statements like, if you get something like, if Joe is here, then Terry is not. All right, we have an if-then statement, so it's J horseshoe T, but we have this not, so the tilde goes here, and that's perfectly fine. That's perfectly well formed because that is negating the letter T. And essentially, you could put, the tilde in parentheses or brackets with the letter, and that would be okay. It would be kind of silly, but the idea there is you have a letter, horseshoe, another one, and that's the way that works. Okay, work on some of the practice problems, and if you have any questions, give me, let me know.